All right, continuing on, and just a matter, again, of rewriting. Of course, if I were asking you to do a derivative, you would look at this and you would say that you had to do product rule. There is no such thing as a product rule and a quotient rule when it comes to integration. So the rewriting that would be required on this is that you distribute your 2x. So you would have 2x squared plus 10x dx. And at this point, this is just like what we were doing just a few minutes ago. You are allowed to integrate these terms individually. Now, as I told you, you don't have to actually rewrite it and show me, you know, the integral of this plus the integral of this. That's just something that you can do in your head. All right, the 2 is a constant multiple. So using your power rule, you would have x to the third divided by 3 plus 10, again, is a constant multiple. Using your power rule on x, so increase your power by 1, divide by your power plus c. Okay, so we would have 2/3 x cubed plus 5x squared plus c. And like I told you, you can always take your answer, take the derivative of your answer, and you should, well, in this case, you would actually come back to this step right here. All right, number 9, rewriting this one. And same thing you had to do when you had a derivative. If you have a radical, you do need to rewrite this. So that would be times y to the 1/2. Then what you would want to do is actually go ahead and multiply these two together. Of course, if you're, you know, multiplying your y's, you're supposed to add your exponents. So you're going to end up with 3y to the 9/2. All right, so our 3 is just a constant multiple. So we need to increase our power by 1 and then divide by our power plus c. Okay, now I'm dividing by a fraction here. If you divide by a fraction, of course you learned in elementary school that that's the same thing as multiplying by the reciprocal, okay? So if I have this divided by this, I change it to multiplication and I flip this. So that means I'm actually going to end up being multiplying by 2/11. And typically when I know that my power is going to be a fraction, I just usually go ahead, I usually don't even write it this way. I usually just go ahead and say, okay, well, we're going to do times the reciprocal. But if you want to show this step and deal with it this way, that's perfectly okay. All right, so I just simply end up with 6/11 y to the 11/2 plus c. Okay. Now, this one's showing a quotient, but remember what I said, there is no such thing as a quotient rule. So we've got to do some rewriting. First of all, you would want to rewrite this as x to the 1/2 power. And then the next step that you could take is bring x to the 1/2 power to the top. Of course, that's going to cause you to have to change to a -1/2. And now take the x to the -1/2 and distribute through the parentheses. So that's going to end up giving you x to the +1/2. So when you multiply this times this, remember you got to add your exponents. So that's going to give you a +1/2. And then you'll have plus x to the -1/2. And now you'll be able to do your integration, okay? So make sure with each of these steps when you're rewriting the problem that you do continue to write your integral sign until you actually start the integration process. So this is just power rule for these terms. So here I would increase my power by 1, which is going to give me a 3/2. Now instead of dividing by 3/2, remember you multiply by the reciprocal. And that way you just don't have to deal with that complex fraction. Okay, plus, all right, so this is a -1/2 power, so I'm going to increase my power by 1. So that's going to give me a +1/2. And then instead of dividing by 1/2, I'm going to multiply by the reciprocal of 1/2, which means I'm multiplying times 2, and then plus c. And actually, you don't even have to rewrite anything by going ahead and multiplying by the reciprocal. Okay, number 11 here, of course, we've got to deal with having some trig functions. Now, 4 is a constant multiple. I'm going to go ahead and take a step here and rewrite it. So, just like we've done earlier, you've got 4 times your function. You can just pull that out front. So, you're looking up your integration rule for sine. And when you integrate sine, you get negative cosine plus c. So, therefore, you could just write this as negative 4 cosine theta plus c. Okay, one more here that's a trig function for us to look at. All right, what you're going to want to do here is to distribute, because again, remember, there is no such thing as a product rule, okay? So it's not that you're not allowed to, if I didn't have this, then yes, I could integrate those two terms individually, but because I have this multiplied, I'm not allowed to do that. So use your distributive property, and you'll have secant x times tangent x minus secant squared x. Okay, so see, now I have it fixed to where I have this minus this. Okay, so if I've got a sum or a difference, I am allowed to integrate these two things individually. So if you look at your list, if you integrate secant tangent, that integrates to be just secant. And then you have the rule that if you're integrating secant squared, you get just tangent. So your answer, well, I didn't mean to put the parentheses. You can just ignore that. So your answer is secant x plus tangent x, and then of course your plus c.